Imagine a child lying in the grass at dusk, watching sunlight fade into the evening. Now imagine that child asking the simplest of impossible questions. What if I ran after that light? Could I ever catch it? That question changed the world. More than a century ago, a young Albert Einstein asked himself the same thing. He imagined riding beside a beam of light, keeping pace with it across the emptiness. But the picture refused to behave. Light, he realized, would never sit still beside him. No matter how fast he imagined himself moving, the light would always rush ahead at exactly the same speed. And so he began to wonder, what if the problem wasn't the light at all? What if it was the way we thought about space and time themselves? That thought became the beginning of a new universe, one in which time could stretch, space could bend, and nothing could ever outrun the light. Before Einstein, people thought of the cosmos like a great unchanging stage. Objects moved across it, but the stage itself, space and time, stayed fixed. Einstein shattered that illusion. He discovered that the stage moves with the actors. When something speeds up, the universe quietly rewrites its rules to keep the light's pace sacred. Clocks begin to tick more slowly. Distances shrink along the direction of travel. And all of it happens so that every observer, no matter how fast they move, always measures light's speed to be the same. It's as if the universe is an orchestra, and light is its tuning note. No matter what instrument you play, a slow-moving planet or a racing photon, everything adjusts itself so that the harmony stays perfect. The result is profound. The faster you move, the stranger your experience of time becomes. To you, everything feels normal, but to someone watching, your seconds stretch, your length shortens, your heartbeat slows. Reality itself flexes to preserve that single cosmic rule. Light always wins. Now picture a spacecraft leaving Earth, engines roaring, accelerating faster and faster. At first the stars seem to shift just a little. Then the light ahead starts to blue shift, gathering energy. Behind you, it reddens, stretching out. As you near the speed of light, every push of the throttle buys you less and less speed. Your ship hungers for more and more energy, yet gains only the smallest fraction of momentum. It's like trying to chase your reflection in a mirror that moves away as fast as you do. You can keep getting closer, 90%, 99.999% of light speed, but each step costs exponentially more effort. By the final fraction, the energy you'd need is infinite. No star, no civilization, no universe has that much to give. Even the most powerful machines humans have ever built, particle accelerators that hurl atoms to near light speeds, can only graze the edge. Their particles circle so quickly that their internal clocks almost stop, yet they never quite touch the light itself. The barrier isn't a wall, it's a horizon. The faster you chase it, the farther it recedes. And so the universe doesn't say no, it simply makes catching light impossible in principle. A race whose finish line forever stays one step ahead. Time. To most of us feels solid. It ticks forward, steady and predictable, like the rhythm of a heartbeat. But in Einstein's universe, time is not rigid, it's elastic. It bends and stretches depending on how you move. Imagine you're inside that near light speed spaceship. Your engines hum, your instruments glow, and everything around you feels perfectly ordinary. You glance at your wristwatch. 1 second passes, then another. But for someone watching you from Earth, those same seconds take longer. Your heartbeat, your ship's blinking lights, your very thoughts, all move in slow motion from their point of view. You don't notice the change because you're moving with time's flow in your own frame of reference, but the outside observer sees your entire world slowed down. This is time dilation, the most haunting consequence of special relativity. The faster you travel, the slower time runs for you, at least from the viewpoint of someone who stays behind. At light speed, time would stop entirely. A beam of light experiences no passage of time at all. To the universe's fastest traveler, there is no before or after, only a single eternal moment. That's what makes light so mysterious. It doesn't move through time the way we do, it simply is. Relativity might sound like philosophy, beautiful, strange, abstract, but we live inside its consequences every day. Take the GPS satellites orbiting Earth. Each one carries an atomic clock, measuring time with unimaginable precision. They circle thousands of kilometers above us, where gravity is weaker and their speed is enormous. Because of these two factors, both predicted by Einstein, time on those satellites runs differently than it does on Earth. Their clocks tick slightly faster due to weaker gravity and slightly slower due to their high velocity. The difference adds up to microseconds every day, tiny, but enough to throw navigation off by kilometers if uncorrected. To make GPS work, engineers must constantly adjust the satellite's clocks using Einstein's equations. Every map, every direction, every location tag on your phone is, in a small way, an act of relativistic compensation. Einstein's theory isn't distant, it's inside your pocket. It guides airplanes and ambulances, moves goods across oceans, and tells us where we stand on the surface of our spinning planet. Even the skies confirm it. High above Earth, cosmic rays, particles born from distant explosions, slam into our atmosphere, creating showers of smaller particles called muons. These muons live only for millionths of a second, far too brief to reach the ground. And yet, they do. Why? Because to them, racing at nearly light speed, time itself slows down. They experience the journey as longer lived than it would appear to us. Einstein's time dilation keeps them alive just long enough to strike the detectors we've built on mountaintops and in laboratories. Relativity isn't just a theory, it's a daily reality, unfolding silently above our heads. There is a strange poetry in this, that motion itself can shape the flow of time. It means there is no single now in the universe. Two people moving differently, one standing still, one flying past, may each experience their own version of reality, both equally true. To the universe, there is no absolute speed, no universal clock. There is only relationship between you and the light, between space and time, between what we see and how fast we move while seeing it. We often imagine the speed of light as a barrier, but it's really a mirror, showing us who we are and where we fit in the grand pattern. It's the universe reminding us that we are not separate from its laws. We are made of them. And so, when you look up at the night sky and see the light of stars billions of years away, remember, you're not seeing them as they are, but as they were. You are witnessing light that has crossed oceans of space-time, each beam carrying with it the memory of time slowed, stretched and twisted by the vastness it traveled through. Every starlight shimmer is a message from the past, moving at the only speed that time itself allows. Imagine again your ship racing through the dark. You've been accelerating for months, years, maybe centuries. Each moment your engines push harder. Each moment the stars ahead drift infinitesimally closer. But something invisible is happening. The faster you go, the heavier you become. Not in the everyday sense, but in the deep physical sense of energy. From the outside, your ship's resistance to acceleration grows. It takes more and more effort to achieve less and less gain. Eventually, each push of your engine adds almost no speed at all. The energy you pour in doesn't make you faster. It just increases your momentum, your inertia, your unwillingness to be moved further. It's as if the universe itself is quietly saying, "That's far enough." At 99% of light speed, you'd feel the barrier looming. At 99.999%, the effort required becomes staggering. More energy than your ship could ever produce, more than your star could ever emit. By the final fraction, the numbers break all meaning. To reach the speed of light, you would need infinite energy, and there is no infinity to borrow from. The cosmos is vast, but not infinite in that way. Light, in this sense, is the only thing free of weight. It alone can travel at that sacred speed, because it carries no mass to resist it. Photons glide through the universe unburdened, pure energy, unanchored by matter. We, made of atoms and gravity and history, can only ever follow behind. So what happens if you still try? Let's imagine, purely in thought, that your ship edges closer and closer to that forbidden velocity. To you, inside, time continues normally. You sip your coffee, check your instruments, and everything seems fine. But for an observer watching from Earth, your world has slowed to a crawl. Your clock barely ticks. Your engines glow brighter as they pour out radiation, yet your velocity changes by almost nothing. To the outside universe, you have become nearly timeless, frozen in motion, hovering just below the cosmic speed limit. And to you, the universe ahead has flattened. The stars in front of you are compressed into a narrow tunnel of blue light, their wavelengths shortened by your speed. Behind you, the universe stretches into red. The stars fade, drawn thin by your motion. The faster you go, the more the universe itself distorts. The distances between galaxies, between atoms, between moments, all twist into strange new geometries. You are no longer traveling through space and time. You are warping them. You could cross the galaxy in what feels like hours or days, while millions of years pass outside. To you, time has slowed. To the cosmos, you are racing toward eternity. The laws that protect light speed are not cages. They are the structure of existence itself. If you somehow broke them, you wouldn't just move faster. You would move outside of time's order, into something beyond meaning. Causality, the sequence of before and after, would unravel. Effect could precede cause. Reality would no longer be reality. And so, the universe simply refuses to allow it. Humanity's greatest machines, the Large Hadron Collider, particle accelerators around the world, already perform this impossible chase on our behalf. Inside their rings, protons whirl at 99.999% of the speed of light. Each lap brings them closer to the edge. Their mass, as seen from our frame, becomes thousands of times greater than when they were at rest. And yet, even with megawatts of power, they can only ever approach the limit, never touch it. They are like runners sprinting toward an ever-receding horizon. No matter how far they go, the horizon remains the same distance away. We have found no loophole, no secret passage, no cheat code in physics that lets us break the rule. Not with rockets, not with warp drives, not even with the wildest theories of negative energy or tachyons. Every path circles back to the same truth. The speed of light is not just a speed, it's a boundary condition, the edge of how space and time can behave. Even light itself can't go faster than light, because faster has no meaning at that scale. It's like asking what's north of the North Pole. There is no beyond. And maybe that's what makes the rule beautiful. Not frustrating, but humbling. The speed of light is the universe's way of saying, you may go far, but you may not see it all. There will always be mystery ahead of you. Even though we cannot reach the speed of light, we are not imprisoned. We can approach it, chase its effects, and learn its secrets. Astronomers and engineers have already begun to live alongside its strange rules. We send probes to the edge of the solar system, photons across interstellar space, signals racing to distant planets. We build satellites whose clocks must account for time bending itself. We observe particles from cosmic explosions that defy ordinary intuition, proving that light speed is more than abstract. It is a law woven into reality. Our dreams of starships and hyperspace may remain science fiction, yet the pursuit itself is luminous. The universe reveals itself more fully to those who chase impossibility, even when the finish line forever recedes. In chasing light, we learn the limits of matter and the vast freedom of thought. There is something profoundly human about this limit. It reminds us that we are small, not powerless but finite. Our lives unfold at speeds far below the cosmic threshold, yet we are capable of imagining the extremes. We can measure time in fractions of seconds that matter only to atoms, and still witness the vastness of billions of years. We can observe light that left its star before Earth itself formed. We can detect particles that traveled across galaxies, living shorter lives than we can comprehend, yet arriving here to prove the elasticity of reality. The speed of light teaches patience and perspective. It whispers that the universe is older, larger, stranger than we can grasp. And it shows that some journeys, no matter how impossible, can expand our minds far beyond our body's limits. So we chase, not to win, but to understand. We accelerate, experiment, observe, calculate. We race toward the light, knowing full well we cannot overtake it. And that is the beauty of it. Every attempt stretches our knowledge, bending our imagination toward truths older than stars. Every photon that reaches our eyes tells a story of motion, time, and distance intertwined. Every particle in our accelerators humbles us with the reminder that even the tiniest object carries mass, and mass cannot escape its cosmic bounds. We cannot reach the light, we cannot overtake time. But in trying, we see the universe in its deepest glory. The light races ahead, eternal and untouchable. We follow, and in following, we become more than observers. We become participants in the cosmic dance. The speed of light is not a prison. It is a horizon, a guide, a measure of all that is possible. It teaches us humility, curiosity, and wonder. It reminds us that the universe has limits, and in those limits, infinite beauty. And so we keep running toward the light, not to catch it, but to see the universe as it truly is.